Good morning, boys. Today we are going to do some properties of the inverse trigonometric functions. Now, by now you all are aware of the principal domains of sine inverse, cosine inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. Now, as we have already seen, they form two groups. Group 1 is sine inverse, tan inverse, and cosec inverse, whereas group 2 is cos inverse, cot inverse, and sec inverse. We know that all the inverse trigonometric functions which fall in this category, they have quadrant 1 and 4 as their principal range, whereas those who fall in this category, they have quadrant first and second as their principal domains. Now, as we proceed to do the properties of the inverse trigonometric functions, we'll observe that these groups are maintained throughout, meaning thereby that all these functions which fall in this category, they have similar properties, whereas the ones having which are a part of this group have another set of similar properties. So let's see how it works. Now, the first kind of property is that if you have to find the sine inverse of 1 upon x, it comes out to be cosec inverse x. Now, if you go through page 42 of the book, you will see that after this, something like this is written, that is x is greater than 1 or x is less than or equal to 1. Now, what does this mean? Why is this constraint given to us? This is, as you all are aware, x means the members belonging to the domain of a function. And clearly, if we are talking about cosec inverse x, we know that the domain of cosec inverse is this, and hence this constraint. So this result is valid for this constraint, that is these values taken up by x. Similarly, the remaining results. So let's just do a quick proof of these properties so that you will understand that we are not simply taking it like that. There is a reason behind this property. Again, in a manner similar to what we had done earlier, we proceed the same way. So let sine inverse 1 upon x equal to y. So this will give us sine y equal to 1 upon x. Easily we can write it as x is equal to 1 over sine y, but 1 over sine y is cosec y. This gives us, taking this cosec to this side, cosec inverse x is equal to y. So we started with sine inverse x equal to y, and we have arrived at cosec inverse x as y. From these two, we conclude that sine inverse 1 upon x is equal to cosec inverse cosec inverse x. Clearly, why do we write this? Because both of them are equal to have the same right hand side, and hence the left hand sides are also equal. Same way, the next property is cos inverse 1 upon x is equal to sec inverse x, and it will be defined for the domain of sec inverse x, which is x is greater than or equal to 1 or x is less than or equal to -1. Same way we proceed. Cos inverse 1 upon x equal to y, let's call it 1. This implies that cos y equal to 1 upon x. This implies that x is equal to 1 upon cos y, which is sec y. Taking this sec to this side, we get sec inverse 1 upon x, sec inverse x is equal to y, which is 2. From 1 and 2, we get cos inverse 1 upon x is equal to sec inverse x. Likewise, we can prove similar results for tan inverse 1 upon x is cot inverse x, which is valid for x greater than 0. Let tan inverse 1 upon x equal to y, call it 1. This gives us tan y equal to 1 upon x. This gives us x is equal to 1 over tan y, which is cot y. This gives us cot inverse x is equal to y, call it 2. From 1 and 2, we get tan inverse 1 upon x equal to cot inverse x. Exactly on the same lines, we can do the remaining 3 results, that is cosec inverse 1 upon x will be equal to sin inverse x. Sec inverse 1 upon x will be cos inverse x, and cot inverse 1 upon x will be tan inverse x. Now here, if you notice, all the 6 trigonometric functions have similar results. So here the topic of 2 groups being formed doesn't come into the picture. Now all have the same results. Okay, so now let's come to the next set of properties. Now here you will see a segregation, that is we have sin inverse minus x is minus sin inverse x, tan inverse minus x is minus tan inverse x, cosec inverse minus x is minus cosec inverse x. Similarly, we have cos inverse minus x is pi minus cos inverse x, cot inverse minus x is pi minus cot inverse x, sec inverse minus x is pi minus sec inverse minus x. Now here you can see that all the group 1 inverse trigonometric functions, they are giving us one kind of result, whereas all the group 2 inverse trigonometric functions are giving us yet another kind of result. A simple proof is can be seen, which we'll do in the next video.